from a steel beam to the whole vehicle protection, from a weld to comprehensive protection. 26 23-seat electric sightseeing cars, with 18 complete cathodic electrophoresis processes, to create a super corrosion-resistant frame, preliminary peeling off surface oil stains, and cutting fluid to reduce the load of boiling degreasing, through soaking in high temperature and alkaline degreasing agent. Completely remove all residual grease on the frame surface, to ensure the metal surface is completely clean, ensuring that subsequent silane treatment and electrophoretic painting can be tightly combined, to avoid problems such as paint film peeling and wrinkling. Through 2 water washes, use industrial circulating water to wash the frame, residual degreasing solution and wash down oil stains, double cleaning, to ensure that before the frame enters the silane tank, there is no alkaline substance residue on the surface. Rinse the frame with deionized water, to remove impurity ions from the previous water wash. Avoid calcium and magnesium ions from ordinary water, affecting the quality of the conversion film. The core conversion film process. On the metal surface, a layer of nanoscale silane chromium conversion film is formed. It improves the adhesion of electrophoretic paint to metal, ensuring the paint film firmly grips the frame like roots. It provides the first anti-corrosion barrier and improve overall corrosion resistance. Phosphate-free environmental protection process replaces and reduce heavy metal emissions. The quality of conversion film is the core foundation of electrophoretic corrosion. Uneven film layer will directly lead to poor adhesion of electrophoretic paint, and later peeling and rusting. 2 pure water washing processes are necessary steps to enter the electrophoresis pool. The second pure water wash removes silane bath residue, ensuring the quality of electrophoresis. If silane bath liquid remains on the frame surface, it will cause during the subsequent electrophoresis pinholes, bubbles, and sulfurization in the paint film, affecting the electrophoretic quality and corrosion resistance. The second pure water wash can completely rinse away the silane bath, ensuring the cleanliness of the frame surface, providing the best surface state for the core electrophoretic process. The third pure water wash thoroughly purifies the surface, to ensure that the frame before entering the electrophoresis tank to the cleanest state, as the last step of the pretreatment process. The third pure water wash is the final check before electrophoresis. It completely removes all residual impurities on the frame. The coating ensures that when the frame enters the bath, in an absolutely clean state, avoiding defects in the electrophoretic coating from the source, ensuring the stability of the electrophoretic process. And the final protective effect. The 11th step is the core process of the whole process. Unlike ordinary painting that only covers the surface, cathodic electrophoresis uses electric field too. The paint particles are actively adsorbed to every part, including the inner cavity, welds, and sandwich, and inside pipes. It can reach the dead ends that ordinary painting cannot, achieving all-round and no dead-angle protection. It blocks rust from the source. The first UF ultrafiltration water washing, recycling excess paint, ensuring a uniform surface, and realize resource recycling. It can also gently wash the surface of the frame. The second ultrafiltration water washing, thoroughly clean the floating paint, and prevent sulfur particles. After the first ultrafiltration wash, there may still be a small amount of floating paint. The second ultrafiltration washing can further clean it, to minimize the residual floating paint. 4 times of pure water washing, to remove ionic residues. After ultrafiltration washing, there may be a small amount of ionic impurities. If not removed, it will cause the paint to turn white and speckle, affecting the appearance and corrosion resistance. 4 pure water washes can completely remove these ions. After drying, the paint film maintain a matte and uniform texture without any appearance defects. It also enhances the compactness of the paint film. After water washing, the joints and crevices of the frame and inner cavities will have water residue. If they directly enter the drying furnace, the water will heat up and evaporate, causing the paint to bubble, which seriously affects the protective effect and appearance. Make sure the frame surface, including dead angles, residue to prepare for subsequent drying and curing. Drying and curing is the key step for electrophoretic paint to form protection. The high temperature of about 180 degrees can cause the electrophoretic paint to cross-link. It changes from liquid to solid, forming a hard and dense paint film. The cured paint film has strong adhesion and not easy to fall off. It can effectively isolate corrosive media such as air and water. 18 electrophoretic protections. It prevents rust, salt spray, moisture, and aging from the source. The welds are not corroded and the inner cavity is not rusted. The frame is more stable and safe. A good sightseeing car is not only a comfortable experience now, but also a long-term safety companion. From the invisible frame electrophoresis to the visible smooth driving, Helita always puts safety and durability first. 26 models of 23-seat electric sightseeing cars, using automotive-level electrophoretic process to escort your scenic spot operation, to ensure every trip is safe and worry-free.